Watch this short video presentation to understand how to make a strong structure using triangulation and thereafter completing the task below. I have a straw in front of me here. This is not strong enough. If you bend it, it will bend. It can't break because it is plastic. But the very same straw made into a triangle will show you how strong triangles are. I am pressing on the 3 points and it shows you, and I'm bending, it's not bending. To show you how powerful triangles are, I'm going to use toothpicks and gummies to construct a structure that hopefully is strong enough to hold this book. We'll start off making the structure with gummies. They are really lovely and tasty. Make sure you don't eat most of them before you complete your structure. Okay, the last one to go. Now what I've done is I've made a lovely square. Can you see that? A lovely square. I've added on more squares onto the structure of mine to see how strong this is. When we added on our squares, this became a cube. Can you see that? Now I'm going to try and test to see how strong this cube is. I'm going to place this book on top of the cube. Let's count. 3, 2, 1. Oh no, it's flattened the shape. One of the big challenges that we run into in this particular design is that it is all built out of parallelograms. A parallelogram is a shape that has opposite sides parallel and equal in length. You can see when we placed the book on top of the structure, the connectors, these are our connectors, are not that strong. So instead of staying up just like this here, the whole thing, let's try it again. And it flopped or flattened. Instead, let's rebuild the structure using triangles. This is so lovely working with gummies or little marshmallows or sour worms cut up. Now I've made this one triangle. What I've done is I've added on more triangles to my one shape. Have a look at that. So what I've done now is just added on 1 triangle, 2 triangle, 3 and 4. So you've got 1 face, 2 face, 3 face and 4 face, all held together by connectors. This shape is called a tetrahedron. Tetrahedron. Now look at this. I'm going to show you. I am pressing on the connectors. I'm pressing on the connectors on every side. It is quite stable. It's not flattening even when I'm putting pressure. So I'm just going to add on more triangles to this one shape. I have done, can you see that? This is the shape I've added on. I'm just going to show you what I've done here. Let's put that in there. No, it's not flat enough. Okay. I'm just adding on triangles. Okay. Now have a look at this. I'm going to add on triangles till I have enough structure to support this book. This is nice. Now let's try it. Are you ready? 2, 3, 3, 2, 1. Oh, beautiful. Fantastic. These triangles are not flattening like a parallelogram. These are not flattening like a parallelogram. The triangles are braced against each other for stability. Can you see that? You press on any part of it. It's nice and strong, and it can support this book. The triangles, as I said, are next to each other, against each other, and they are braced together for stability. Even now, these little connectors we use are not strong enough by themselves, but because they have been made into triangles, they are able to hold this book. You know, when I think about it, I use triangles all the time when I build things. When we built a water tower recently, we used triangulation for strengthening and for stability. I hope you've enjoyed this. I would love to see all your structures in one of our teams meet. Thank you.